Okay, very cool. Hello, friends. Welcome to WDB lecture something. This is the nth backend lecture and the second installation of cloud-specific technologies. So in terms of agenda, the things that we're going to be learning about is first EC2, so basically hosting your own web server on AWS Cloud. And then after that, we'll take a deep dive into a serverless architecture in terms of using API gateway, AWS Lambda, and DynamoDB as a sort of database. I know you haven't learned the use cases of databases just yet, so this will be a very a preview into what you'll be learning in the future. But the purpose of adding on DynamoDB is to just get started on what we're going to use this serverless architecture for, if that makes sense. So let's go ahead and start screen recording and get started. Okay, cool. Welcome to my computer again for the fourth time, I believe. Yeah, for the fourth time. And let's go ahead and log into AWS. So nobody here has AWS accounts just yet. However, we'll be giving AWS logins very, very soon so that we could run AWS on your own machines or have access to AWS on your own machines. There we go, in order to do the cloud homeworks. So stay tuned for that while I release that. Let me also hide meeting controls and let's get started. Okay, so this right here is the AWS homepage. This is your first time seeing it, and that's totally okay. But essentially, like all of our cool AWS stuff will be here. If you want to create an account, then you could easily do that up here in create an AWS account as it loads. Yeah. So right now, you could just create a new account if you want to. Go ahead and fill out all of your stuff. And what this is going to do is it's going to create a root account. Now, this is a very specific distinction in that you're making a root account instead of a personal account for an organization. So the root account acts as your overall organization, whereas your personal account is just a branch of that organization. So it's a way of having a tiered level. The root account is more like super admin. You should only use it when you're accessing billing and stuff, and then you delegate access to users from there. So that's what I mean by root account or a personal account here on AWS. I will be giving personal accounts to you on WDB's own AWS infrastructure instead of the actual root account access because it's connected to my credit card. And I don't want y'all to steal my credit card information. But yeah, let's go ahead and log in. If you click create an AWS account, oh, okay, maybe not that one. That is a-okay. We'll sign in this way instead. Also, I have a feeling that my internet is extremely slow because I have so many tabs open at the same time. Also, just a warning, and this has happened before in the middle of teaching, but one time my computer overheated and then blue screened in the middle of lecture. So if that happens, I will try and join back as soon as possible. Where did I put it? Oh, there it is. Okay. So this is my username and password. I'm not going to tell you my password for obvious reasons. And you are greeted by the AWS console here. You could go ahead and search up for the different kinds of services that you'll be using. AWS has like 176, something like that. More than 100. There's a lot of services. But today we're just going to focus on 4 different core services. So let's go ahead and focus on our first service, EC2. So this right here is our EC2 console, and you get to see a lot of different kinds of information regarding EC2. What EC2 is, it's your own personalized private server that you could do stuff on. One other thing about EC2 is that it is an instance or a snapshot or a slice of whatever AWS has. So AWS has a bunch of data centers and compute centers all across the nation, and they have very powerful servers that have hundreds of cores, terabytes of memory, and a lot of GPUs and so on and so forth. Just know that you're not actually going to be using all of that memory, all of those cores, right? That would be extremely expensive, but it would be possible. So instead, what AWS does is that it takes a very certain snapshot of this processing power and gives it to you. So let's say that AWS has 172 cores, and you order a 1-core instance, then it will just allocate 1 core of AWS's entire infrastructure and hand that to you to use. What do I mean by that? Let's go ahead and spin up a running instance. Okay, cool. So these are our instances. Let's just go ahead and launch an instance from here on out. So this is the instance launch wizard, and you could do a lot of cool stuff with this. For example, you could choose which specific operating system that you want to use for your instance. In our specific use case, the most easiest one to use is Amazon Linux. So let's go ahead and just set this instance or Amazon machine image. And what an Amazon machine image is the type of instance that is going to be given to you. So the number of cores that you have, what kind of operating system that you're going to use. If you remember from our last cloud lecture, we were describing the different kinds of levels of cloud. So you have software, you have platform, you have infrastructure. Right now, we are in the very basic low level of infrastructure. So we're giving you access to a specific server. However, Amazon deals with the operating system, the virtualization, and the networking for you. So we're on that specific level right now. Also in the chat, we have a question of what exactly an instance is. And an instance is just your own personal machine or computing instance on the cloud. So in our specific case, an EC2 instance is just your own tiny little server that has X amount of memory, X amount of cores, X amount of computing power, and so on and so forth. Does that answer your question? And I'll be diving deeper into exactly what an instance is as we go along. So for this specific Amazon instance, we want to launch it in Linux. We're going to use an x86 processor as opposed to RAM or ARM, sorry. And in addition to that, we will be using the free tier eligible because we are stingy here at WDB and we don't have a lot of money. So we're going to use as much free stuff as physically possible. One thing to note is that you have a lot of different kinds of instances that you can choose. So for example, you have a lot of instances where you have the choice of having 1 CPU versus 64 CPUs or even 48 CPUs. In addition to that, you could choose your memory or how much RAM you have. For the free instance, it's just 1 gigabyte of memory. However, you can go up to crazy amounts like 192 gigabytes of RAM. You can also choose to add your own memory. So for example, add your own SSD cards in case you need to store a lot of data in your instances. And one last thing is that you could have network performances. So if you're running a Minecraft server, you want to have the fastest internet possible. For example, gigabit speeds. Otherwise, if you don't necessarily need the network performance, you can start to optimize whether you want moderate or low to moderate. Also, as for why this one is not free tier, I honestly have no idea because like you said, it is quite frankly worse than the current version of free tier. So I have no idea why this is not free tier eligible. Well, when quite frankly it should be, but you know what? If we could get double the memory, we're gonna take it to tell you the truth. One more thing is that there's a lot of different classes and different kinds of families of instances that you can choose. So one example is that there's a lot of like general case instances or general case families in which you can do anything on it. So there is not necessarily any optimization towards data storage or networking or databases or so on and so forth. However, you can get into different kinds of instances, and let's see if they have the names here on the side or if I have to explain it. Okay, they don't have the names, so hopefully I can get through all of them. But in terms of instances, you could create your own database instance, which is optimized for database servers. You can create your own instance that's optimized towards compute, so very powerful computers in your instance. You could also have instances that have a lot of memory. So if you're doing memory type caching, that's important for your use case, then you could customize your instance to be more optimized for your specific use case. So that's what the types of families are. Sadly, I wish that they had the names of the family other than R5 or R4, but that's something that you could look up. And quite frankly, all we need is a T2 instance, which is your general case kind of instance. So let's go ahead and review and launch this. So yeah, these are all of your details, what kind of server that you have, what kind of performance that you'll have, the security groups. You don't necessarily need to worry about that unless you're doing a VPC, which we won't get into since we're just doing web dev stuff, and then more details here and so on and so forth. So let's go ahead and launch this instance. One more cool specific thing is that you need a specific key in order to access your instance. So that's why you have existing key pairs here. So we're going to go ahead and just create a new key pair since we want to be able to access our instance. WDB lecture. So I'm going to download this key pair, and then I'm going to launch this instance. So now it's going to launch this instance, and now you have your own little bubble on AWS EC2 in which that you can do a lot of cool compute stuff. In our specific case, host your backend web server. So let's go ahead and view our instances. So this is our current instance. It is still running, so we don't have that many details. The most important and core thing to worry about launching an EC2 instance is this right here, your public IPv4 address. And that is the only way that you're going to be able to have users access your specific kind of instance. So if you're hosting a web app or a web page on EC2, then you need to be able to route all the traffic to your instance. And you can do that by using the public IPv4 address and then connecting this address into an internal domain name. So if you have your own domain name, you can just connect it to EC2 or have EC2 do the routing for you through AWS. So this specifically is the raw address or the computer readable address of how users will get to your backend server. So hopefully our instance is running. Yes, it is. In order to access your instance and in order to actually put code into your instance, you would have to do that through the terminal. So let me go ahead and do that right now. If I could find my terminal. There it is. Okay, cool. So let me just copy this address. And let me go to where I downloaded the PEM file. So what did I call it again? Yeah, there we go. Okay, so now that we are here, we have our PEM file here, which is how we access our instance. And this is just a permissions file in order to, it has a very secret key. And this is so that no other attackers can actually access your instance, only you can. So we have that level of encryption, that level of access. So in order to access it, just use your SSH commands. So SSH using the key of wdb_live_lecture.pem. This is just to specify that we're using this specific key. And if this instance was not protected, then you could just SSH straight into it. But since we have a permissions file, we need to add this. So after you add that, then you are going into ECT user. And then you're going into your specific domain, which is 54.153.62.184. So let's go ahead and SSH into that. Say yes. And now you're on your EC2 server. So as you can see, there's literally nothing here, not even Node, not even Java, I believe. So this EC2 instance is extremely barren. There's nothing on it. It's like buying your own server or buying a new laptop. You have to install everything from there. So if you want to install Node, you have to do so through using the command line interface. If you want to install Python, you have to do so using the command line interface. I'm not going to go into the details of how to do that. Since it's just a quick Google search and quite frankly, it's just following instructions. But again, install Python Linux using command line. For example, if we want to install Python, we could just look that up, copy all the things that we need. So I think specifically we're doing this, or actually, I don't know if we have apt-get. Yeah, we don't have apt-get, so you have to do yum install. Yeah, we have yum. So if you know what that is, go ahead and do that. Otherwise, like, you don't need to worry about that. So if you have your own Django or Node service that is already set up for the backend, all you would have to do is transfer all of your files into your EC2 instance using your command line, and then you'll be able to run it from there. Any questions so far? Okay, cool. I see no questions, so I am moving on to actual serverless. So the reason why I bring up EC2 first is that if you're developing your own apps and you're running it from your own computer, the easiest way to or not the easiest way, but the um, original way is to put it on a server and expose endpoints to that server so people can access it. So sending GET requests, sending PUT requests, sending push requests is all done using this EC2 server. And it's a very basic in that you just develop the code, drop it into a server, expose a server, and you're done. However, there are certain problems with that. So one of the big things is globalization or load balancing. AWS does indeed have its own load balancing service, which you can do. However, that sometimes is a pain in the ass to configure. In addition to that, if you're just hosting a web server on your own computer or on your own server, then whenever your computer or server reaches its capacity, then your website will start becoming extremely slow. So there's a lot of things going on in terms of scaling and load balancing that you have to worry about if you go to this deep level in terms of cloud. However, if we want to move on into a more quote unquote elegant process and have AWS expand things for you, then that's when we get into the serverless architecture of API Gateway, Lambda, and potentially DynamoDB. So I'm just going to go ahead and introduce API Gateway first, and we'll go from there. So right here again, if we go to our AWS console, we could just go ahead and click into API Gateway. And here we go to API Gateway. From here, we could create our own API. And as Alex has taught you, we're going to build a REST API since we love our REST APIs here at WDB. We're just going to call this the WDB test API. Call this from live lecture. And as for the endpoint type, don't worry about it. Just call it regional or edge optimized. Either one of these two is fine. For now, let's just do regional, and we can create that API. So here we could actually start defining our methods. So what Alex taught you is that you could have certain resources that you can build or certain certain resources that you can build that you could request information to or send requests to and get a response back. So you would actually be able to just build that here in API Gateway without actually having to specify code to do that for you. So let's say that we're building a recipes API and you want to get a specific set of recipes from your API. Then you could do it here from API Gateway. So let's go ahead and create a new resource. We could call this resource recipes. And we could also specify that if we want to get a specific recipe, like what Alex taught you in terms of like replacing the resource name, then you could do that by specifying the resource path here in curly brackets. However, for our case, we'll just make a very simple API and just call it regular recipes that they have to request. From here, we enable API Gateway CORS access, and CORS, just enable it. I don't want to explain it, but just enable it. And if you enable it, then you will not have any headaches later down the line. So just enable that. And then we can create our resource. From there, we can start adding our own methods to our API. Also, if you enable CORS, then you have your options endpoint already built in for you. And from there, we could just start adding more methods. So let's say we want to create a GET request. We could simply do that by attaching GET to it. So we create our new API, and we have our GET request right here. As for integration type, we're going to use a Lambda function since we're since the main core of serverless is AWS Lambda or functions as a service. And I'll get to that later, but that's what your current integration type you want to is what you want to be. Next up, use a Lambda proxy integration, and that's just to make the events sent to your Lambda function much more readable. We'll get more into that later, but be sure to enable that. And then as for your Lambda region, that just specifies where your Lambda functions are living. So right now we are in the Northern California region. And if you remember from Cloud Lecture 1, these different regions have different kinds of AWS services available to you. In the case of California 1, I believe all of these services are available to you. So no need to worry about region. This is only if you want to change where your customers are. So if a lot of your customers are in, for example, Ohio, then you could set up a endpoint in Ohio, and it'll be much faster for all Ohio users instead of Northern California users. Or if you want to create an endpoint in Northern California, then it'll be much faster for people living near Northern California. So that's where the region comes into place. We also haven't created a Lambda function yet, so sadly we cannot fill this. So I'm just going to put a sample Lambda function. Let's just do tutors get, and then we could save that. We'll give it permission to invoke our Lambda function, and now we have our get. How is it? Okay, there we go. And now we have our get method execution. We can go ahead and test it. However, it probably won't work since I connected to some random Lambda function, but that is a-okay. This is simply how to connect your endpoint or your API into whatever backend code that we're using. And as for the backend code, that's where AWS Lambda comes in, since all of your code, all of your logic will be living on AWS Lambda. So let me just pull up AWS Lambda right now. So Lambda functions are a very specific type of thing in serverless in that you have a lot of control over what you do. So, or you don't have a lot of control. You delegate a lot of the control to AWS. So things in terms of load balancing, things such as expanding the number of instances that are running. Sorry, Pennsylvania just updated. But there's a lot of instances that you're running. God, I lost my train of thought. Oh my God, I'm so sorry. But like, let me take a step back. So for EC2, we were talking about load balancing and how if you reach the limits of your server or you reach the limits of your computer, then your API can no longer catch up. So you need to add load balancing or a way to add the amount of servers that you have into EC2 or into AWS to do that for you. However, with AWS Lambda, all of that is just built straight into the Lambda function. So in terms of how many Lambda functions you can have, it all depends on how many people are queuing it. So if just one person is queuing your Lambda function, then AWS will just create one instance of your Lambda function. However, if 100,000 people are queuing into your Lambda function, then AWS will scale horizontally and develop 100,000 different instances of your Lambda function, each of which to serve each of these 100,000 users. So a very simple way of scaling widely in order to accommodate for different kinds of use cases. Another beautiful thing about AWS Lambda when compared to EC2 is that with AWS EC2, you pay by the hour. So for every single hour that your instance is running, you pay a fixed amount or this certain amount. However, with AWS Lambda, you pay for the amount of time that your function takes by the closest hundredth or 100 milliseconds. So if you try to make your Lambda function as fast as possible, then you save a lot of money in the long run. But another big thing is if you have your EC2 instance on for several hours and it's only queued once, then you get pay for several hours worth of EC2. However, with AWS Lambda, if only one person queues your Lambda function in a few hours, then you only pay for that one instantiation of that Lambda function rather than the actual instance or the hardware running in the background. Does it make sense? I am assuming yes. Okay, cool. So that is one of the beauties of AWS Lambda when compared to EC2. And there's actually a name for this. It's called Functions as a Service. And since they're called Lambda Functions, it kind of makes sense as Functions as a Service. But the reason why they call it Functions as a Service is that you just upload code and all of the load balancing is done for you. But yeah, Lambda, OP as fuck. It's beautiful. You should use Lambda. But yeah, let's go ahead and create our very first Lambda function. Create a function. Our first Lambda function. And as you can see here, you could choose different kinds of runtimes. So if you are very familiar with Node, you could actually create a Lambda function using Node. Or if you're very familiar with Java 11, then you could just use Java 11. As for me, I'm extremely familiar with Python. So I'm just going to use Python for this. But depending on what kind of language, what kind of use case that you want to use, you can choose the one that you want. I'm kind of confused on what exactly REST API is and why this is a REST API. Okay, so in terms of what makes this a REST API, what I believe Alex mentioned was the representational state transfer. Yeah, so you are able to send a certain state from your client side onto your API, and then your API can do cool stuff depending on what the state is provided from your client, and then return that back to you. So API Gateway and Lambda so far don't make this a REST API. It just makes it a regular API. But how you build it can turn into a RESTful API. So for example, one of the key components of a RESTful API is that the REST API doesn't care about state. All of the state is either stored on a backend database or stored on the client side. And then all you're doing is requesting information from the API. So that specifically is not necessarily inside the API itself, but rather how you develop the API. Does it make sense? Hopefully, kind of, maybe. Okay, cool. So yeah, moving on. This is Python 3.8, and let's go ahead and just create our Lambda function. Give it some time. Give it some time. So how's everybody? Okay, no, never mind. No more small talk. Okay, so our Lambda function has been created. As you can see, you have a very simple template here. So everything in our Lambda function passed in is a JSON object, and everything passed out is also a JSON object. For specifically Python, we can import JSON as our specific use case to do that for us and do all of the cool things. So one other thing that you need in AWS Lambda is your Lambda handler. The reason why you want this Lambda handler is that if a certain event gets into you, then how the hell does AWS Lambda know how to process it? Well, it uses the Lambda handler and it takes up two specific parameters, the event and the context. So I'm just not going to do anything to this for now. I'm just going to save it as is. Notice how I'm just returning a simple 200 status code, and notice how I am just returning a very simple body of hello from Lambda. So I'm not going to change anything. I'm just going to leave this as is and hook this up directly onto API Gateway. So let's go ahead and change this Lambda proxy to be API Gateway. This is our first Lambda function. So let's go ahead and save that. Okay, cool. Now we go into our method execution and test this out. Let's go ahead and press test. Cool. We sent a test request to recipe, and we get a very simple hello from Lambda, as well as our whatever response headers we have, and all of the logs from launching this API gateway and launching this Lambda function. So again, very simple, very nice. But we're not done yet. Let's say that this is our very simple API and we want to deploy this immediately for the entire world to see. We can't necessarily do that yet. We have to do a few more actions in order to actually make this feasible. The first is to go into the Actions tab and then actually deploy our API. So I will put this into a new deployment stage. And if you're familiar with CS61B and you're familiar with Git, think of this as like different kinds of branches of your API. So you could have like test stages, deployment stages, or production stages. And this is just to make that delegation of whether or not you're testing something in your API in terms of like new features and stuff, and you don't want that to be accessible to the current users of your API. So some specific use cases is that you have your production API, and that's the API that the entire world sees and uses. Next up, you have your deployment API. So this is where your staging API, where you could just drop deployments there and then eventually migrate them into production. So if you're using any kind of last minute testing, last minute QA, then you could just drop it into staging before merging into production. And then you could have a testing or dev API. And this is where you can add new API features, new endpoints, and so on and so forth. So that's what our deployment stage would be. Right now we don't have any, so let's just go ahead and make a production stage right off the bat. Let's call this main API stage. And similar to GitHub, you could actually put descriptions onto your deployments. These are like your commit messages, if you want to think of it that way. So we could just do this as first deployment. And this is really useful for if you want to track how your API changes over your time. You would do that for your deployment description. So let's deploy this API. And again, we're still not done. One more thing that let me take a step back. So now that we've deployed our API, we now have a invocation URL. So we can do a lot of cool invocation stuff here. However, as you know, this isn't a valid stage. This is not recipes. This is just production. So you might want to put recipes there and then do stuff there. However, notice that we're missing an authentication token. That's because we actually haven't granted anybody access to our API yet. So the way AWS works is that it works on a very granular level, a very secure level. So in terms of AWS, it doesn't allow access unless you tell it to allow access. By default, everything is secured and everything is closed to just you. And that's just how AWS works. It's very safe, very secure. So the next step that we have to do is actually enable worldly access to our APIs. So let's go ahead and do that. Okay. So on the very left, you have things called usage plans and API keys. Your usage plan actually dictates how somebody can use your API. So usage plans can go to very nitty-gritty details. For example, how many times somebody can call your API per second, how many times somebody can call your API over a certain month. You could assign different kinds of usage plans and create different API keys. Depending on who you want to use your API. So for example, if you're building a test API or a staging API, then you want to create a very specific usage plan just for the engineers who are testing your API. However, if you're deploying to all the customers immediately or all users immediately, then you want to create a usage plan that allows for unlimited access. I already have an unlimited access usage plan here, but I'm going to just walk you through creating this plan ourselves. So just hit create here. We'll just call this a basic plan. It's basic. And then now we could add our throttling. So this is what I was talking about before. You could only do this many requests per second, or as for burst requests, I'll get into that later, or you could only do this many requests per day, week, or month. So you have that level of granularity in order to limit access and also to prevent people from using your API just in case it's expensive to pay for. So right now I'm just going to put the default. I think it was not 5,000, like, was it 5? Oh, I don't remember the default, but I'm just going to put 500 requests per second as a rate and 1,000 for a burst. And a burst is just if a lot of people are using the same API key and a lot of people call your API at the same time. That's what the burst would be. So let's go ahead and, I need to enable requests per month. Let's also do 1,000 because I don't remember the regulars. So let's go ahead and add an API stage to WDB test. We could attach this plan specifically to prod or production, and then we could save it from there. Now we go into next. And now we could go ahead and create an API key to this usage plan. So let's go ahead and create an API key, basic key. We could just auto-generate it. You could do custom if you want, but I'd rather just auto-generate it. So let's just auto-generate a key. We now have a basic key attached to this usage plan, and we are done. Now we have our usage plan. Now we have our API key. Oh, it's over here. I clicked. Damn it. Let's go back. Let's click our API keys. And now we have our very basic key. And if you have a security enabled, then you need this API key in order to be able to access our specific usage plan. So let's go ahead and do a test run using Postman. There you go. As we wait for Postman to load, I am just looking at CNN. Go Bears. Okay, now that Postman is loaded, let's go ahead and access this API that we just built. Looks like I don't have any requests yet. Signed in. So let's go ahead and make a new request. WDB get request. No description. I'm just gonna save it as is. Oh, I guess I need to add it to a collection. WDB. Okay, cool. So let's go ahead and enter our request URL, which is in resources, or sorry, not resources, stages, production, and then our invocation URL. Oh my God, why is my mouse doing this to me? Okay, let's go ahead and go to Postman. Oh, okay, there you go. Drop this in. Also know that we called the recipes resource, so we're queuing the recipes resource. One more thing to double check is to make sure that you don't have any authorization on. So in our specific case, we have no authorization. So I think we should be able to do this. We should be able to access it. So no authorization, no headers, no body. Let's see what we got. Missing authentication token. Okay, it'd be like that sometimes. Let's go ahead and just add our authorization then. Let's go to API keys, basic key, short API key. Let's add this to our headers. Authorization. I think it was x-api-key, I think. Let's go ahead and add that to our value. There we go. No body, no headers, no authorization, no parameters. Let's double check API gateway to see that we didn't say anything. Production, we're using our basic key. We have our ID. Our resources should be ready. Recipe. Oh, did I spell recipe wrong? Yes, I did. It's recipe. There we go. And then send a GET request. Hello from Lambda. So our use case goes from a request from anybody onto API gateway, which handles the actual request, pushes that through Lambda. Lambda has all of the logic, pushes it back to API gateway, and then pushes it back to us, the user. Also, it is a lot of steps, but it actually was very fast, 79 milliseconds. So yeah, that is a basic overview of how you get from a basic API onto the final stage of Lambda. Any questions so far on this three-step process? None. Okay, cool. Now let's go ahead and add some actual beef into this sandwich that we're making. So right now we just have bread. We have spread a little bit of mayonnaise, maybe a piece of lettuce. But to be honest, this is a very basic sandwich. We want to add pastrami to the sandwich, or if you're vegetarian, tofu, or deep fried tofu. That actually sounds delicious right now. I might order that for dinner. But yes, we want to add some actual substance into this API we're building. So let's go ahead and add that substance. I will exit out of Postman for now and go back to our first Lambda function. So again, like I said earlier, everything in Lambda is handled as an event. So what exactly does this event look like? Well, let's go ahead and dump the event and find out. You could change it directly into the editor and deploy from there. And then we could hop onto Postman and then get live changes. Internal server error. Okay. Apparently you can't just dump the event. So I'm just going to send the event as is. Oh, one more thing. In case you get errors like that, you could actually jump into monitoring and see exactly what kind of metrics is being generated by your Lambda function. So for example, you get a lot of Cloudwatch metrics and you get to see just how many errors and successes there are, the duration of all of your Lambda functions, and how many times it was invoked in the past several hours, or whatever custom time frame that you want. In addition to that, you actually get to see logs here. So right now it's taking some time for Lambda to actually post that into Cloudwatch, which is, or at least I think it's called Cloudwatch. Yeah, Cloudwatch, which is where everything is logged in AWS. It takes some time for it to get there since it does a very lazy way of actually loading this data. So you might have to wait 5 minutes in order for everything to refresh, or you could just like mash the refresh button, which is what I usually do. In addition to that, you could just click into this URL and see the kinds of things that Lambda is telling you. So as soon as Cloudwatch loads, I can show you. Loading events. Okay, cool. So as you can see, you get very basic event information like the start of your event, the end of your event, what kind of reports that you have. So this is very boring stuff, but in case you have an error or if you have print statements, all of your print statements and all of your errors will be funneled into Cloudwatch and will be shown right here. So if we have an error, again, it takes some time for everything to propagate. You could see exactly what errored here, since we know that our Lambda function failed earlier. Let's see if Cloudwatch says why it errored. Yes, so as you can see here, our success rate went down from 100% to 0%. Oof. And we could see that kind of information live here on Cloudwatch. Again, let's see if this has updated. Cool, it's updated. It's finally there. So again, click the Cloudwatch metric and you could see exactly why your Lambda function failed. Name Eve is not defined. What? Did I really just call it Eve and then? Okay, so maybe we could just dump the event. That is fine. Oh, I can't control Z. No. Okay. Also, I can't believe I have to talk about this. But sometimes Lambda has these really weird errors that just happen. So for example, what you just saw, for some strange reason, it didn't get the NT, or maybe I was stupid. Maybe I'm just gonna watch this recording and see that I just typed out Eve. But sometimes Lambda has the possibility to not actually deploy the entire Lambda function. So if you do like a very quick fix change, like dumping the event instead of an actual like string, then for some strange reason, okay, thank you. I'm not going crazy. Yeah. So Lambda sometimes has these weird propagation errors. And if you have no idea what's going on, try deploying again to make sure that nothing weird happens. So yeah, that's apparently the error since, oh my God, yeah. So Lambda is weird like that. So make sure that you're checking for that just in case you get weird errors that you don't think should happen. So let's go ahead and try this again. Okay, cool. So we get a lot of things from this event. It passes in, for example, what kind of resource it's being queued for, what sort of path is being queued from, the specific kind of HTTP method that was used to invoke this event. In addition to that, you have a bunch of headers, which I will not go into. Same thing with what kind of multi-value headers, which I'm not going into. And the specific thing that is interesting is something called query string parameters and stage variables and path parameters and multi-value parameters. So what exactly makes this important? Well, let's go ahead and add a query parameter. And I think you could see where I'm going with this. You could add a test param here. Call this value hello from WDB and send that. If you scroll down here, we now have a specific kind of query string parameter. And this is given to you in a sort of dictionary object. So test param is assigned to hello from WDB. And then you could actually, sorry, another key, praise the Lord. You could actually start adding more and different kinds of query test parameters in this sort of thing. So we could add a test param to and put bruh and add more things and so on and so forth in order to send into our actual data. In addition to that, this is actually how you would access body parameters. So rather than accessing query string parameters, you would access the body parameter in our JSON object. So this is actually how you are able to handle those kinds of events. So let's go ahead and do that. Oops, I deleted way more than I needed to. Okay, there you go. So one cool thing that we can do is set up query params is equal to event, specifically the query string parameters. I think that's what it's spelled. Cool. Oh, underscore q. Oh my god. Okay, fine. Yeah, underscore or lowercase q. So set your query string parameters to be your event. Let's go ahead and see if that works by sending over our query params. Query deploy this. We'll go ahead and check again with Postman. And as you can see, deploys from Lambda actually operate very, very fast. So very cool. Oh my god, bruh. Okay, so let's go ahead and check Cloudwatch and see what happens. I have a feeling that maybe you are actually supposed to capitalize that. Unsure. Let's see if that's what actually happens. Okay, so yeah, something weird happens. But oh god, it's easy. But essentially the actual event, then you could actually, oh, I forgot what I did. So with the event, first you have to deserialize it since the event is a JSON object. So JSON.loads your event. And what JSON.loads does is that it actually takes your JSON object and actually converts it into a readable Python object. So if you want the analog between Python and JSON, you could think of JSON as a Python dictionary, right? So it even has the same kind of syntax, the curly braces, the dot dots, and you could have nested JSONs. So that's what I personally do to think about how JSON structure works in relationship to Python. So hopefully it might work for you as well. So let's go ahead and redeploy this. Still an internal server error. That is okay because we have our logs. So let's go ahead and jump into our logs, see what happens. Oh, did I not? Okay, monitoring. There you go. Okay, let's go ahead and jump into what these logs are saying. Any moment now. Okay, so key error, query string parameters. I honestly have no idea what. Okay, wait, let me quickly. Wait, where'd it go? There it is. Let me quickly just dump the regular event because I have a feeling I just spelled something wrong. I'm just going to directly copy and paste it since that is just the easiest way to go about things. Where is it? Where is it? Where is it? Not body. Query string parameters. Okay, I am just going to take this, Control C, and then Control V. Did I really not spell it wrong? Okay. Well, let's go ahead and deploy that. Let's go ahead and dump our queries parameters. Query params, redeploy, and send another request. Oh my god. Okay. So that's what it's supposed to happen. I have no idea why it's not doing that since I've done this a million times before, but whatever, we'll leave it as is. One thing is if you're building a post request, then it would be the opposite. You would set a body to be whatever the body is. So body. And you could actually see this here in, but essentially like in the actual message, there would have been a body parameter, and that's where you would actually send your payload into our specific API or into our specific Lambda function. Where did this go? There it is. Okay. And one thing that you can do, or one thing that I do a lot, is to validate a lot of these Lambda functions. You could actually do that directly in API gateway. For example, if you go to your GET request and go to your method request, you could actually specify what kind of query string parameters that you're expecting. But I just do that all in Python, since it's much easier to have everything centralized into code rather than spread out across a bunch of different services. So one of the big things about serverless is to manage your complexity. Where are you going to put the bulk of your logic? Where are you going to put the bulk of your code? For me specifically, I put a bulk of the code into AWS Lambda, since it is a function as a service, and that's where everything should be, in my opinion. However, if you want more granularity, you want more control, then you could add certain bits of logic into API gateway if you so choose. I'm simply teaching you how I work with AWS Lambda and how AWS says that you should. But again, it's totally up to you. There's a lot of different ways to navigate a serverless architecture. And it's, again, up to you on how you want to build this and whatever works for your specific use case. For my specific use case, this is the best for me. So yeah. Oh, one more thing in terms of an actual architecture is that what I like to do is actually delegate a lot of different Lambda functions for a lot of different resources. So for example, if you are making a post method or a put method, then you would make a new method here in API gateway. That part you'll have to do anyways. But in terms of what kind of integration request you're doing, I could actually do multiple different Lambda functions. So I do one Lambda function for get, one Lambda function for put, one Lambda function for post, and any sort of Lambda function that, or any sort of method request that you're using just has its own unique Lambda function. One other thing that you can do is actually connect everything into the same Python code. So for example, you just have a generalized recipes Lambda function that handles get, post, put, patch, all of that stuff, all in just one function. And you could actually do that because if you remember from one of our previous invocations, it actually told you what kind of request was sent into this Lambda function. So you could actually bake in and build in logic into one Python file in order to navigate that correctly by doing a switch statement or Python's version of a switch statement or a bunch of if-else statements in order to navigate to the right part of the code. Personally, I don't like doing that. It is simpler to have everything in one piece of Python code, sure, but then you have to do a trade-off of time complexity. So in terms of the branching, in terms of what kind of functions are being loaded, that could save you valuable time or cost you valuable time. Since AWS Lambda is on a 100 millisecond basis, you're trying to shave off as many of the milliseconds as possible in order to cost you the least amount of money. So by segregating everything into its own specific function, for example, the get function, the post function, the put function, then it's much easier to shave off seconds that way, and that you're not loading up extraneous different kinds of methods or extraneous different kinds of files. It is a lot harder to maintain in that you have a lot of different kinds of files in your repo, but it is easier in the long run in order to be able to create that sort of spacing. Also, it really helps in terms of readability and not having a bunch of spaghetti code, so that's another very big thing. Okay, going back to this, I am just going to print the keys of this, and I really hope that it will tell me what kind of keys are available. Oh my God, okay. Okay, that is okay. But now that we have the sort of grounding and baseline ready, we could actually start connecting AWS Lambda into a bunch of different kinds of AWS services. So let's go ahead and get our very first taste into NoSQL databases or JSON-based databases. In our specific case, we're going to be using DynamoDB here in WDB. God, so many acronyms. Okay. So let's go ahead and jump to DynamoDB. From here, you could start actually creating your own table. So go ahead and create a table there. And then you are greeted with the very basics of what's going to be your NoSQL database. To take a step back, I'm just going to say that a NoSQL database is a unstructured database. It can be structured depending on what you put into this database, but in general, it's very, very loose in what kinds of items that you could be storing in this database. So of course, you have your very classic thing like a table name, so the recipes table, and your primary key, which is like, if you think of this in a Python dictionary sort of sense, the key value pairing. The primary key is what kind of key in order to access this pairing. So I'm just going to use ID. You could also add sort keys, and I will get into the time space efficiency of sort keys later, but for now, don't worry about it. And you could use default settings, create the tags, and so on and so forth. But for now, we're just going to move forward. So in this specific kind of recipes database, I use the term NoSQL and unstructured because that's basically what it is. You could store any kinds of information in this database that have nothing to do with each other. It's bad practice, but it's something that you could totally do. So for example, if I create a recipe for spaghetti, I could add different kinds of things. So for example, I could add a number like the cooking time. Spaghetti takes 30 minutes or something. I don't know. I don't make spaghetti. But you could also add things like a string, like country of origin. And then you could put like, not Florida. You could put Italy into your country of origin, and just a bunch of different kinds of data types. Like for example, a number set, a map, a list, a Boolean, Booleans. Oh no, you can't do Boolean sets. But yeah, like a Boolean. So those sorts of things. Or a binary object, which is just the raw 0 and 1 bits. So you could add a lot of different things. Let's just go ahead and just create this very simple spaghetti item. So yeah, we have our row, we have our resource, we have our columns, cooking time and country of origin. But this doesn't have to be the same for every single item. Let's go ahead and create a new item called gnocchi. I think that's how you spell it. If not, I'm so sorry. You could have a completely different set of columns associated with different kinds of rows. So instead of a cooking time, let's say that we are weird and we want a cooling time. And the cooling time will also be 30 minutes. And instead of a country of origin, you could also, oh, thank God. Nice. Thank you. I'm glad I spelled it correctly. You could also add things like a where I ate this, and you could just say home, save. And then as you can see, because we are using a unstructured database, we actually have a segmentation of different kinds of rows in this database. So DynamoDB doesn't care what you put into this database. If there are certain rows missing, or if there are certain null values in the rows, it just adds it in anyway. This is why we get, again, into the unstructured portion. Later on, you'll be learning about regular SQL databases, which store structured data, tabular data. And again, the main difference between SQL and NoSQL is the fact that NoSQL is unstructured and SQL is very picky on how you store your data. They must be this specific kind of row. Each of these rows either has to be filled. You have to do a lot of like tabularization, for lack of a better word. And that's just the sort of things that you need to deal with a SQL database. There's also a lot of trade-offs between a NoSQL and a SQL database, but again, we'll get into that when we actually talk about databases. But for now, again, we just have our regular DynamoDB table right here. So in our regular Lambda function, or in our very first Lambda function, we can go ahead and start adding things like using this database. And how would you go about attaching this database into our Lambda function? Well, that's simple. You simply import AWS, specifically Boto3. So what Bodo3 is a wrapper for AWS. So AWS has its own command line interface or CLI tool, but you don't necessarily need to use that. You could just import Bodo3 and use all of the Bodo3 functions. To take a quick tangent from what we're learning so far, I'm just going to Google Bodo3, DynamoDB. And looking at this documentation, you have a lot of different kinds of things that you get to learn. For example, deleting items, deleting tables. The thing that we're currently worried about is getting items, querying items, putting items. So that sort of thing is what you can do in DynamoDB, in Bodo3. So yes, we could use the user interface in DynamoDB, but that's not very good for our specific use case. But everything that you can do on the DynamoDB UI and then some, you could actually do programmatically using Bodo3. And this is a very great tool in order to actually interface with AWS in terms of actually doing the items in an automatic fashion. We'll get more into Bodo3 later, but again, very cool stuff. So specifically with our very first Lambda function, if we want to get a specific recipe, we would import Bodo3 and then take another step forward is setting a DynamoDB object or an actual resource object from Bodo3. So using Bodo3, you would create a new resource specifically for DynamoDB, and this is your new DynamoDB object. Once you have your DynamoDB object, you can create a new table from this DynamoDB object. So for example, we want the recipes table. So recipes DynamoDB equal to DynamoDB dot table specifically called recipes. One thing to note is that I might actually have to specify a region name. I think it's region equals, where did I put this? US West 1? Oh, US West 2, okay. So you could specify a region name. So if your database is in a different region, not recommended, but if you have to access a different region, you can do it this way. You could type in US West 1 or 2. I think that's how you specify a region. Let me double check, wait. Table region, DB. It's whatever. We'll just trust this process. If it's wrong, we could just change it later. But essentially, that's how you instantiate a very new DynamoDB table object. From there on out, you could actually start querying items from this table. So let's ignore this query params for now and say that we want to get a specific item from DynamoDB. We would simply do recipes DDB dot get item. And specifically, we want to specify a key for this item, and the key ID pairing would be whatever we specify. So let's say we want to get the gnocchi object. Let's go ahead and drop, not query string parameters, still triggered from that, but gnocchi. There we go. Let's go ahead and set this to be a response. And let's go ahead and just return this response and see what happens. Also, I have a sneaking suspicion that something will error. Let's find out why. Let's deploy and let's run. Okay, so it has an internal server error, but that was expected. Does anybody know why we got an internal server error though? Anybody? Anyone? Okay, that is fine. So The answer that I'm looking for is that we actually don't have permission to access DynamoDB. So I don't know if you remember from Cloud 1 or earlier from this lecture, but AWS really likes private access to everything. It's very, very conservative on who gets access to what specific kinds of resources. And if it's not explicitly specified, then AWS is just not going to give you the access. So the same thing here. Our AWS Lambda function, it's trying to access a different resource in DynamoDB, but it doesn't have the actual, not requirements, the actual permissions to access this database. Because of that, you would have to go to permissions and actually assign DynamoDB access to this specific Lambda function. So we go into this execution role, which is just the permissions specified with this Lambda function. You don't have to worry about IAM. It's not within the scope of this course. But if you get into these weird errors where you cannot access a specific resource, you could just attach a policy from there. So from here, we could attach a DynamoDB specific policy. For example, DynamoDB full access. Or actually, we'll do read-only access for now. Read-only access, so it could read from tables. And now we have DynamoDB read access attached to our IAM policy. Also, Georgia is really close right now. Oh my God, it dropped to 1709, but okay. Configurations. Let's also go to monitoring so we could see specifically what is going on. We have attached our policy, so that is good. We do not need this anymore. We do not need this or this anymore. Okay, cool. So let's go ahead and check the specific logs, specifically what errored. Wow, my internet's so slow today. Oh my God. Anyways, oh, that is such an old log. What the hell? Okay, wait. Oh my God, it's the same. Okay, we have to wait for Cloudwatch to update. Super annoying, but it'd be like that sometimes. Oh, there we go. We got a timeout error there. Okay, cool. Also, I want to see what errored before that. DynamoDB. Wait, did I just spell DynamoDB wrong? Oh, okay. Well, aside from these very stupid syntax errors on my part, another very big thing is the specific kind of configurations that you have. So if I was not a dum-dum and actually spelled things correctly, then you would know that Dynamo. Okay, and you would know that you wouldn't actually have access to this specific kind of table in DynamoDB. So that's another thing that you have to do in case you want to attach your Lambda function to different kinds of AWS services. So you can connect it to DynamoDB, which is what we're doing here. You can also connect it to EC2. So you could actually create an API that interfaces with EC2 and does really cool things with EC2 just with the click of an API call. And that's what makes Boto 3 and AWS in general extremely powerful, is a kind of diversity and utility offered to you by just using the interface provided to you by Amazon. Microservices are very cool. Let's try this again. Is it taking forever again? Oh my God. Oh my, okay, it is fine. It is fine. So yeah, that is the certain kinds of things that you do with DynamoDB. Let me actually show you a request that works. Where is it? What's a very simple request that I do? Okay, messages request. Oh, actually, no, that is not simple because you actually need to specify stuff. That's good, yeah. a not simple example, but an example of something that already works. As you can see here, we do the same exact thing of creating a new DynamoDB resource and specifying a new table resource with this function. In addition to that, notice how we have another Lambda handler here that requires everything. Also, it is lowercase q for query string parameters. I have no idea why our event was not loading it, but it'd be like that sometimes. But that was how you would load the actual event. And then going on from there, you would actually start interfacing with DynamoDB. So in our specific case, this line right here is that you would get your tutors DB and you would get an item, specifically a key item with an ID and whatever parameter that you have. So in our specific case, we would type in gnocchi here rather than specifying the query string parameters from earlier. Don't worry about attributes to get. It's just what kind of columns that you want to get. Nothing too important. But yeah, this very specific setup is actually very similar to our previous Lambda function setup in that that is the baseline that you need in order to actually get this information. Also, we have 9 minutes left, so I sadly will not be able to show you how post requests works or any extraneous requests on top of that, but I'm just going to quickly fix all of these issues and actually elicit a request that we can access. So one of the first things that I'm going to do is just say fuck it and build a new database in Northern California, since that just seems to be the easiest way to do this. So I'm just going to create a new recipes table with an ID key with default settings. I am going to go into items and add some items. Hello? Table being. I'm also going to jump into our first Lambda function and fix all of these kinds of errors. So I think the first thing is that we actually don't need to load the event. The second case queue. The next thing is that we import Bodo3. Also, why is this not updated with, okay, whatever, that's weird. Next, we do DynamoDB, which I'm just going to short to DDB, to a new Bodo3 resource. DB. In addition to that, DB recipes database is equal to ddb table of recipes. I think I called it recipes. Yeah, I called it recipes. So it would be that. One more thing that we do is go into recipes underscore db dot get item of a specific key item where the ID is equal to gnocchi. Let's go ahead and switch to DynamoDB and add our gnocchi item. So gnocchi. Let's add a new string called country of origin, or coup, Italy. And let's add a number of time to cook, or TTC. We'll do in 30 minutes. Let's save that item. Now gnocchi is in there. We get a response from this of gnocchi. And then let's go ahead and return this response. One more thing that we can do is that we could just test this immediately up here. So you can create test events. I would not recommend doing relying on this though. You should definitely create like robust tests on your own that don't rely on the UI. But if you want to do a really quick and dirty test, you could do that here. Test. So let's create this and test it out. Let's see why it failed. I am just going to give up on query string parameters. For whatever reason, it is not getting it. So I'm just going to deploy this. Okay, cool. So as you can see here, the DynamoDB request specifically has a bunch of extraneous things actually that we don't need. Here we have our actual item with its time to cook, its ID, and its country of origin. We also get a lot of things like the request metadata, the retry attempts, just things that you don't necessarily need. So in terms of that specific stuff, we could actually just delete that from our request. So, or another thing that I do is just to call a payload to be a response of item. So let's go ahead and drop our payload here and deploy that. See what kind of differences we have. Cool. Now we just have our regular status code and our body, which has our time to cook, ID, and country of origin. One last thing that I want to do is to just get that damn query string parameter thing working. So I'm just going to do, I think, would keys just work, or is it event.keys? I'm just going to do event.keys, and hopefully that'll say something, or print out event.keys. Let's see what it looks like. Dict key. Oh my god. Okay, wait, that doesn't actually help me. That is a-okay. Let's see what Postman says. Okay, I will figure that out next time, because that is supposed to work, and I am so confused at why that doesn't work. But whatever, it is okay. It'd be like that. But in this specific kind of very simple GET request, we can go ahead and send the payload, and it'll return it back to us in Postman. Why did it not return it back to us in Postman? Oh my god. Okay. Maybe I have to redeploy. Hold up. Let me quickly fix some stuff. Deploy. Deployment package saved. And run this. Wait. That's not the request I want. Oh, no, that is the request I want. Okay, send. Actually, I'm just going to delete all of this stuff. Minus that, send. Okay, well, whatever the issue is, I actually have no idea what the issue is. But whatever the issue is, there is some kind of internal server error. Well, where for some reason this would actually elicit a good response. I think one more thing. Oh, wait. I have one more Hail Mary in the last 2 minutes before I call this quits. JSON.dumps. Okay, and if we deploy this and do a quick test. Oh, type error. Decimals. Okay, I know how to fix this. I've seen this before, but okay. I say that AWS is amazing sometimes, but there's these just tiny little things that AWS does that makes it super fucking annoying. And you will be learning more about that if you ever decide to pursue a career in cloud engineering. But nonetheless, I'm just going to leave it as that, since it's just very minor errors, some very weird AWS nitpicks. So hopefully you learn. Hopefully I didn't scare you away from cloud too much, given how many weird things errored out. But I don't know if there's going to be a Cloud 3, but if there is a Cloud 3, it'll probably just be 30 or 45 minutes of me finishing up the serverless architecture. So yeah, thank you so much for coming. Hope this was a fun experience. And as always, go Bears.